So scientific notation is part of our notes for 3.2, and it's in here because it sometimes does have negative exponents on a base 10. And scientific notation is just a shorthand way of writing really, really big or really, really small numbers. Examples of this are all over the world of science. When we talk about really, really large things like the number of atoms in a mole of a substance in chemistry, or the mass of the Earth, or the distance to the sun. Really, really large numbers are often used, or sometimes very, very small numbers. So maybe the diameter of a cell, or parts of a cell when we look at the microscopic world, or even beyond that to the molecular world. So we can have really, really big and really, really small numbers. And if you're going to write it out with all of the zeros, it gets to be a bit laborious. And so scientific notation is just a shorthand way of writing that. Oftentimes people have remembered this from some point. And just as a reminder, really, really big numbers have positive exponents, and really, really small numbers have negative exponents. I'm going to explain this a little bit more if it isn't something that's being jogged into your memory. This is the standard form for scientific notation. And so A out front here has to be between 1 and 10, and the exponent on base 10 shows how many decimal places you had to move in order to get it there. A long time, or oftentimes in math, it's easier for me to show you, not to tell you. So the example for A is 120,000 is a fairly large number. If I wanted to write that in scientific notation, I would write it out as 1.2, because that makes my digits between 1 and 10. And in order to get the decimal from where it was to where it is in the 1.2, I had to move it 1, 2, 3, 4, 5 places. So that would be times 10 to the positive 5, because I'm representing a very large number. Similarly, in E, I want to represent this in scientific notation. In this case, it's a very small number. And so I take a look at my number and write the digits that I see. So a 5 and a times 10. And I have to move the decimal from where it is to where it is in the 5. So I moved it 1, 2, 3, 4 times. I'm representing a very small number, so that is a negative 4. You can think to the left and to the right if you want, but I like to think of this in case, like I had, very large numbers have positive exponents, very small numbers have negative exponents. I'm just going to scroll up, and oftentimes, like I said, oftentimes people do remember these things. So writing these all out in scientific notation, in standard scientific notation, 88 million would be 8.8 times 10, and I have to count my decimal places, 1, 2, to the 7. C, I write it out as 5.2 times 10 to the 3, 6, 7, 8. F and G are small numbers, so writing out the digits that I see so that it lies between 1 and 10, so 8.1, and I need to represent how I got there. I don't want to change the value of this, I just want to change how it looks. So it'd be 3, 6, 9, and it's a negative 9 because that's a small number. These have the same value. You're not changing the value of these, you're just changing the way that they're written. So this would be 7, 10 to the 3, 6, negative 7. You should be able to go back and forth in these. So that was going from standard form to scientific form in all those examples. And now we're going from scientific notation into standard form. So write down the numbers that you see. And this said to the 3. So it's here, but I want it 1, 2, 3. So I would fill in the 0. Oops, that's not the right number at all. That's a 5, and it have 1 0 after. So messy. Sorry about that. Maybe I'll just write that a little bit easier. 1450. Okay, so B, 5, 6, and I want to move the decimal place 4 times, it says. So 1, and then there'll be 3 zeros after, and you can fill them in if you want to see them. 1, 2, 3. So 56,000. The last two are tiny numbers, so write out the digits, and then we want to fill in the zeros. So we moved it 1, 2. So that's where the decimal place is going to go and fill in the 0. Last one. Those are my digits. I'm going to move it 1, 2, 3, 4. That's where it's going to go. So I fill in my zeros. I'd have a decimal place and 3 zeros, and then that string of numbers. So using your calculator with these is really important. Your calculator will have an EE or an EXP button. It will also have a button that looks a lot like scientific notation. It will work 95% of the time, but don't use it. So if you see a button that looks like that, don't use it. If you're in class, we can take a look at each other's calculators and help each other out. But with these ones, I really want to coach you into how you enter the numbers into your calculators. So I'm going to write out the steps. So to enter this into my calculator, this is a series of buttons that I would push. So 2.5. And then this bit here is EE or EXP. My calculator says EXP, so I'm going to put EXP. That's the next button that I push. After that, I'm going to enter the exponent. So 7. I never hit the times button. I never hit the 10 button. This EXP does that for you. Now, I'm going to multiply that by another number in scientific notation. So 3 EXP and 5, and then equals. Doing this on your notes can be helpful for when you look back on this. You're not going to do it all that often, and so it is something, certainly if you're not doing a chemistry or physics right away, it can be something that you forget. So your display should say is 7.5 times 10 to the 12. And the other thing here is what that looks like on your calculator display. So all of us with different calculators is going to look different. Some of us get a little times 10 somewhere. Sometimes you just see the 7.5 and the 12 is in a weird place on your display. So however your display works, it's trying to tell you this, and you would write your answer out in standard scientific notation. So all of these we can give a try for. I'm going to put the answers up. If you're watching this video on your own, you can fuss with your calculator all you want. If it's not working, then it's definitely something to shoot me a message over. If it says write your answer out in scientific notation, it's expected that it's in scientific notation. In the case of B here, if your calculator can display it in standard notation, it will display it in standard notation. So technically those are both right, but you do have to be able to go back and forth between these two. So a few more here. And I'm just going to scroll so I can put the answers to these ones up for you. But really no work to show. Really just using your calculator. C is similar if I want to write it in standard notation. It's not wrong, but writing it in scientific notation is a valuable skill in this. So try and get it squared away in both. All of these examples have been multiplying and dividing in scientific notation, but you can add things in scientific notation on your calculator. And again, if it can display it in standard notation, it will, but you do then need to go back and forth. Some of you will have calculators that lock it into scientific notation, and so I'm putting both on the key. Really, the better one is the scientific notation. So make sure that you're comfortable going back and forth in those and using your calculator. So some word problems, everybody's favorite. So most word problems will be multiplication of scientific notation. I don't want to teach us another kind of word problem. Really, the skill with this is scientific notation and using your calculator and understanding, how to go back and forth between standard notation and scientific notation. So for all of these, we're just going to be multiplying. And so if you're not that into the word problems, take it as a buy. Unless it tells you to divide, we're going to be multiplying. I will support this in a way that makes sense if people are into the word problems. But for the most part, you're just multiplying these numbers. So this number 1 says light travels at a speed. So we have a rate of 3.0 times 10 to the 8 meters per second. We have an amount of time, which is 3.15 times 10 to the 7, because that's how many seconds are in a year. And then we want to know what is the distance. And so that's what we're being asked. If we do remember our DRT questions, distance equals rate times time, or if you're just multiplying these numbers, remember how you enter them into your calculator. Showing my work would look like that. And my calculator would give me 9.45 times 10 to the 15. Always with word problems, you do want to make sure that you're answering the question and including units. But really, like I said, showing all your work in these, this wouldn't be a 3-mark word problem question. We're taking the shortcut of just multiplying these because that's really the skill that we're looking for here. So number 2 tells me what a parsec is. So a parsec is this 3.1 times 10 to the 16 meters. It's a distance. And it says if the distance to the nearest observable galaxy is this many parsecs, how many meters would it be? So this is a conversion. In this case, we want to start with what we know. And if you're not listening to my strategies in solving these, then you're just going to multiply the numbers. This I can see as a converter. So if you've done unit conversions before, you want to sort it so that it cancels things out. Or ignore me and just multiply these numbers. So as we can see here, if you are a unit converter, doing dimensional analysis, which I know some of you have done in other courses, this is how it would look. Or on your calculator, just multiplying these two things, I get 5.022 times 10 to the 25 meters. That is the distance. And again, if it doesn't say anything, you're just multiplying these numbers, and that should serve our purposes for now. The last one does give us a hint, and this is modeling the kind of thinking I'm doing for us here. So it says the nearest or furthest object that can be seen with the unaided eye is the Andromeda Galaxy, and the galaxy is this far away. And so this is our unit converter that we're going to use. So it would be 2.3 times 10 to the 22 meters. And again, using this dimensional analysis, if that's something you've done in other courses, and if not, you're just going to follow the tips here and practice running your calculator. In this one, if you are a unit converter and you're transferring that from another course to this one, then you're going to do it. But otherwise, just do what it says. We're going to divide the distance by the distance of a light year. So 2.3 times 10 to the 22 divided by the 1 times 10 to the 16. So we get an answer of 2.3 times 10 to the 6. And that's going to be in light years. All right. So in this one, there's a Star Wars reference in this one because they invariably use parsecs as a time instead of a distance. I don't know if anybody caught that one in there. Yeah, I think one time I was doing the key for this, my kids were watching a bit of a Star Wars marathon, and it came on just at the right time. They can do the Kessel Run in 12 parsecs if you round down. Anyway. super dorky bit. If you remember that from those movies, cool, and if not, fine too. And in these ones, really the skill we're working on is running your calculator with the scientific notation and recognizing that they are equivalent values. We're just writing them in a different way between standard form and scientific notation.